In this video, we'll continue our discussion of graphing in 3-space, focusing on domain a little bit longer. So find and graph, so we're graphing the domain, not the function. But we can tell we're not going to graph the function here because this has x and y, it's a 2D domain, but I have an x, y, and then the output, so it's a 3D function or graph. However you want to think about it. All right. So we're just going to graph domain here, not the actual function. So let's start focusing on what can't happen. Okay, so I have that denominator, and I know denominators, we want to really make sure that they are not 0. Oops, and oh, there's an error here. I want to put, forgive me, I want to, where are my notes? I want to put an X up front. So if you guys will, fix this. Or I'll fix it in your notes. I'm going to fix it right here. All right, and that is x squared. Okay, not the prettiest, but we get it. Okay. Sorry for the typo. Your notes will be fine. Should be. Okay, 9x squared minus 4y squared can't equal 0, so that means 9x squared cannot equal 4y squared. All right, I can divide here. X squared can't equal 4 over 9. Let's actually turn it around because we're used to thinking about y first. So y squared can't equal 9 over 4 x squared. To solve, take the square root of both sides. So y can't be 3 over 2x. One thing you have to be very careful. You took the square root of both sides. We got to introduce a plus or minus. Okay, so this is just a line. And I'm going to graph this on our graph in a dotted line. All right, so here's my dotted line. Okay, I know the points. That graph starts at 0, 0, and then goes up 3 over 2. So I'm going to forget my computer there. I got up 3 over 2 in both directions. So we get this dotted line here. So I know my graph can't be that line. The negative is going to be the same, but the other direction. All right, and I can use symmetry to put that down here. There we go. All right, so that's what the graph cannot be. So this is how I would graph it. I would say, okay, I'm going to grab my grapher. I'll say green is everything it can be. So it can be anything that is on here. All right, try to fill in as much as I can. There we go. We get the points. All those points except for the points right down the middle. So it can't be, let me make that a little bigger. It can't be that line there. Let's go ahead and change it back. Can't be that line. Can't be that line. Right, and then we could just put our dotted lines back on there if we want. Right, can't be that one. Can't be that one. So literally any point on that graph is part of my domain except for any point that lies on that dotted line. So we have graphed all of the domain. All right, we're going to do another one that's similar to this. Take a look at this graph. Now we have an ln. If you remember from algebra, that our ln's have to be positive. I can't take ln of 0. I can't take ln of a negative. So I know that y minus x has to be greater than 0, which means y is greater than 0. I'm going to dot that. I also know this is a dotted line because there's no or equal to. So we'll do that. So that is, oops, and I messed up. We want an x here, not a 0. Okay, so that's just moving the x over. And then I know that y equals x is just a line right down the center. So it can't be that line there. Okay, I'm going to leave that alone for a moment. We also have our denominator. Our denominator is a radical. And I know radicals, the inside, must be greater than or equal to 0. It can be 0 in that case. So if I were to solve for y in this case, I'm going to move the y over. So I get y is less than or equal to x plus 4. So that line is going to be a solid line, but it starts at 4. So we'll let each one be 1 here. We have the room. And then the slope is going to be 1. So I'm going to follow this up. Here's my 1 there. And I follow this down. Let's see if I can get that. Looks like it's that point, so I'm going to erase that to put a point there. It's probably 4. Actually, let's see. See if that gets me through that. All right, so if I move this up, it's a little, my graph's off. That's the problem, is it looks like the spacing's not totally correct. So we'll call that good. Okay, so how the shading works. Let me shade these in 2 different colors. We'll shade y is greater than x in green. So that was my dotted line. We got a dotted line because of the greater than in the middle is not or equal to. So y is greater than x, so that means I am going to shade everything that is above here. The next one I'll make my highlighter bigger so it doesn't take so long. So I get everything up until that point, that line. I shouldn't be going over the line. All right, so imagine that's not over the line. Imagine I can color within the lines. And then we'll go ahead and shade this one in orange. Okay, this one says y is less than or equal to, so we do get the solid line in this case, and then it's everything underneath. Well, I said I was going to make a bigger highlighter, and then I didn't. It's okay, we can still do it really quick. All right, so where this graph is actually going to exist will be in that strip. So we actually have a full graph that comes out at us that's based on this up here. That graph is going to spit out z values up or below, up above or below this x, y axis. Z comes out at us. So if we were to graph this, and this would be an interesting maybe thing to take to GeoGebra or whatever grapher you use, and you can see you'll have a function that goes down the strip, and then there will be nothing out here. It will just be blank because it doesn't satisfy the domain of that. It's kind of cool because it'll allow us to get that strip. This is how we can get different buildings or something based on 2 different surfaces to just be maybe in one strip or down an alley or something like that. You can use your mind to go to any application for this of restricting domains. That way it fits in a strip or fits in a circle or an ellipse, a bunch of different things that we can require a surface to live within. So focus on domains. They will be important. We are going to start focusing on some calculus based on this like domain idea. Or this is really a projection of my domain almost. In a way, you could call it a projection. So we'll extend this as we go further.